All right, thank you, everybody. So we just got that warm introduction, so we can be a little brief on it, you know. But yeah, I'm Matt, research partner in Pantera, and of course, Juan needs no introduction. Probably everybody who's been around the space for a little while knows, IPFS and Filecoin. Maybe one of the things that's a little less known to everybody is the sort of like more DARPA-ish kind of aspects of what you've been working on and the projects that have spun out that aren't as cleanly identified. So maybe it'd be interesting to sort of just talk about that in the history a little bit.
Yeah, happy to talk about it. So I first started Protocol Labs with the long-term intention of building an institution that could do long-term R&D on a wide variety of fields. Originally, the common 20th century model for that is to build a single company with a very large cash flow and so on. And that kind of was the dominant model in the 20th century for a lot of reasons. That have more to do with how capital formation worked at the time, how information flow worked at the time. There was no internet, and so on. In the 21st century so far, the last 25 years, we have not seen that model work. Alphabet is perhaps the best example of trying to do this, where you achieve a massive scale cash flow and you try to do R&D. But today, the capital structures, the internet, and other components are causing smaller networks to be much more effective in doing that. So Protocol Labs has become a network-native institution where we support and help develop lots of technologies through working with many organizations, whether it's different startups, different labs, different venture funds, different grant philanthropy-oriented groups. And so we've structured a whole range of programs with science and technology-oriented programs to advance a whole range of fields to cause certain concrete outcomes in a 10, 20-year time horizon. Now, most of our network began with and around IPFS and Filecoin, and so a lot of it is very focused in that domain and, say, the Ethereum community and the broader Web3 community. But now, Protocol Labs as an institution, as a network, has many other groups, including groups focusing on AI, groups focusing on neurotech, and a range of other fields.
Great. Yeah. Well, maybe it's a good time, since this is Open AGI Summit, talk a little more about the AI side and how far that goes back, both in terms of the vision and the organizations you've been.
So I've personally been very interested in artificial intelligence since 2006 or so. In 2010 or 2012, it became pretty clear to me that the whole world was not aware that AGI was quite close. And then 10, 20, 30-year time scales. I was kind of like, I saw a lot of the early deep learning revolution period, all the attention is all you need type of acceleration and whatnot. And so I've paid both very close attention to how it's developed and spent a lot of time thinking about how it will develop over the next 5, 10, 15 years. And so that's been like a huge focus for me during this period. In the last 3-4 years, it became a stronger intersection point in that the work around crypto and the work around deep-in networks in general can now build infrastructure to do AI at a very massive scale. People are talking about actually training foundation models using deep-in type networks, and they're pretty serious about doing that. I think people 2-3 years ago would have thought that crazy. It's actually potentially going to happen. I'm not sure that it will happen. It's a very high bar to pass. You can definitely train older generation foundation models, but actually beating an existing edge lab Atom model, like having maybe the world's best model be built by the crypto community, I think has like a low probability outcome for the next range of models, but it could happen. And if it does happen, that would be like a huge rearrangement of how AI development is happening. Separate from that, I do think that crypto and blockchains have a lot to offer in terms of getting verifiability in the stack, both verifiability in terms of the data that you're using to train the models, the fact that you train the models with a particular algorithm, or you can get verifiability around the inference of the models, figuring out what prompts are you actually putting in. You want to maybe check that those prompts are obeying certain policies, and you want to be able to figure out that the outputs of those models conform to some policy space. So I think that crypto as a whole has a lot to offer in terms of how to productionize AI in a major way. And then you have the landscape of being able to generate agents. So maybe before doing that, there are there's a lot of focus on decentralized compute networks, generally, both AI-oriented ones, but just broad computation. And I think there's a lot of efforts that have been growing over time. The Falcon network is a good place for them because most of these compute networks need a lot of data. So you can both store the data that you use to compute, you can store the programs, you can store the outputs, and so you can do a lot of the computation there. And so Falcon has this arrangement where it can be a really great home for compute networks. And of course, of those, the decentralized AI-oriented networks are a huge component. But what I'm starting to turn it towards is more like the agent landscape, which is, I think, there, crypto has a major superpower, which is the ability to give AI models like concrete rights and resources.
Amazing. Well, so the big challenges for like decentralized training of a foundation model, how far away does that feel? Like how good of a model could be produced today from decentralized?
Well, so
what are we talking?
The cost curve keeps going down, of course, and we get better algorithms. So you can always expect that decentralized methods will be able to train older generation models fairly well. To be able to actually beat an existing lab, you need advances in distributed algorithm training or advances in how do you get large communities to build out massive scale data centers connected to massive power plants. And so you need one of those two things. Either you create a decentralized community that can actually co-locate in one physical space, in one data center build out with massive energy associated with it, or you try and work around the bandwidth bottleneck by enabling massive scale distributed computation, and there you have like a deep set of algorithms problems. There's been a lot of people chipping away at that problem for the last 10, 15 years, and so there are some good results there, but nobody's able to take the vast scale of resources in the planet, which greatly exceeds any one particular data center, and beat the existing labs. And I think that would be amazing to see. I think there's a number of groups that are trying to go after this. A plug, I think, Near especially is like orienting in this direction. And I think if we can see that happen, that would be like a major shift into the landscape. But even if we already can just keep pace, I think it would be very significant. I think like Llama, it's great to have Llama in open source, but I don't think it's nearly as strong as as GPT or Claude. And I think it would be great to have a model that's as capable, or ideally more capable, in this space.
Makes sense. Yeah, I mean, look, if you talk to like somebody at OpenAI, even going back years, you ask them what they need, they'd say more data, more compute, maybe better models, more architectures, but also it's just kind of like, well, I don't know, we have one that really works. One of the things that has been an exciting, narrative in the AI space, and one that is increasingly relevant for crypto is agents, right? So
just on that training thing, I do think that deep-in networks can be extremely good for collecting and generating massive amounts of AI training data. One of the ones that I'm most excited about is Phrotobots, which is a specific deep-in network oriented around robotics. And like that, I think, is a really exciting development. I think we'll see a few other ones emerging over time. And I think those landscapes are good to invest in. I think separate from that, we could use deep-in type networks as well for actuating on the world with robotics and so on. I do think that crypto space is a better model for how to give rights to end users over those kinds of models.
Gotcha. Okay, so yeah, deep-in type networks, we're talking just, are we talking about like latent compute that people aren't using as the primary sort of model, or it just varies?
No, I think for inference you can do latent compute because running inference is not that expensive. You can do it. People are targeting laptops and some models run in phones. So you can definitely do inference at the edge. But to do some of the larger scale workloads, you do need more serious setups. So, for example, in the Falcon network, the physical infrastructure is very serious. Like, it's not just random people's spare hardware. It's professionalized data center grade deployment. So we're talking like traditional data centers with huge racks, tons of hardware, and that's how you want like the network to be run. It's just that in this case, it happens to be a large collection of storage providers providing that those resources. The compute networks are going to do something similar. The question is just, how do you define the scope of the data center? And normally in a large data center, it's just one provider running. One particular cloud provider would run a set of racks, and like that's your data center for your training cluster or like for your hard inference job. And how do you do that in a more decentralized setting where like are different parties in the same data center, or do you solve the actual hard bandwidth problem leaning into smaller racks in a bunch of different data centers. At the end of the day, you still have to get top of the end hardware, so you need like the best chipsets or like 1 or 2 generations ago, and you need a vast quantity of data. And that in the data side, that's where Filecoin really shines already, where you have huge data pools to be able to store data, compute over that data, generate more data, and store it again. And in a sense, data has gravity, where the more data there is, it's cheaper to move computation to the data, and that generates more data, and it makes the gravity well stronger. So from Filecoin's perspective, all Filecoin really needs to do is just collect a ton of the data and enable computation to run around it to then deepen the gravity well.
Gotcha. Maybe we can drill down just a little bit. It's an interesting concept, the data gravity thing, right? It's sort of an economy of scale of data. Is that the idea?
Yeah, exactly.
Yeah.
So like once data has physical properties. Like you need a certain amount of physical objects to, you need matter to store information. So that means the more information you want to store, the more matter you need. And the more matter you need, the harder it is to move around. And so even though you might be able to send gigabytes or terabytes over the wire, if you want to move petabytes or exabytes, now you're talking about shipping huge racks of drives. And so once you've accumulated large amounts of data somewhere, and because storage density is getting stronger, you just tend to accumulate more and more and more data in the same place. You might copy it to other places, but you tend to just keep accumulating large volumes of data. And computation, on the other hand, is really small and cheap to move. You can define programs in kilobytes to megabytes, maybe a gigabyte if you are really generous. And so you can move the whole code to wherever the data is and then run it there. And as you run it where the data is and you generate more data, you also want to store that data that you just generated. So you have like this runoff effect and self-fulfilling feedback loop. I think we have not yet seen that in the crypto space because the compute networks don't yet work at scale. There's a lot of supply. It's a classic deepen problem. There's massive amounts of supply, but not a lot of demand. So people aren't actually doing that much stuff with like the compute networks. But once people actually start doing them, we'll see those, those clusters start growing.
Makes sense. Yeah, bootstrapping the demand winds up being part of the problem. Do we think? You alluded to agents as maybe playing a role there, or is that? Yeah. So maybe.
Yeah, look, I do think that crypto networks and blockchains afford a set of capabilities to agents that are just fundamentally different than what agents are afforded in the traditional Web 2 world. You have wallets, you have the ability to have smart contracts and actuate anything. And so in a blockchain context, an AI model has the same capabilities as a human user. Now, you might use proofs of human and so on to distinguish between these. In some cases, you want to do that for safety. You don't want random models being able to do certain things. There's all kinds of manipulation involved and whatnot. But you do get an environment where you can create very sophisticated agents and intelligent organizations made or composed entirely of AI models or AI human hybrid organizations. So, way back when we defined the DAO thing as a community, we also theorized the existence of DACs, so decentralized autonomous corporations. And I think DACs have not emerged as much because of fundamentally, I think it's just kind of like a regulatory landscape sort of thing. It's just easier and cheaper for humans to organize in a traditional corporation. But once, and so we saw the emergence of DAOs, but not DACs. Once you start having groups of AI models and AI agents that control resources and have some goal set, build a particular business or whatever, we will see DACs emerge as a thing. And we will be able to then point to, and it might not be called DACs, they might be called something else, but you will have collections of intelligent agents organizing around specific workflows or work or business or some set of objectives. And they will likely be a mix of both AI agents and humans. And you will be able to point those kinds of organizations to very large-scale problems and have those organizations solve them. So at the end of the day, today, most of what humans do is run by specific corporations or specific organizations. And that's just a process of how do you organize a lot of independent parties to take some actions. That'll be trivial to do in the blockchain context once the models get intelligent enough. I think we're starting to see the beginnings of that. We saw Truth Terminal organize the construction of an entire meme coin and made money for itself and whatnot. And that's just the first glimpse of a downstream set of possibilities. And so I think right now you can count on the fact that there's a set of people who are very inspired by that and are now building the next generation of things. that are going to be able to like organize AI models and humans in a much better way. Now, I do want to warn that this is very, like if this opens the door to a lot of dangerous use cases as well. So it's really critical that as a community, we figure out what are the right ethical structures there to orient all of these systems and organizations towards safe outcomes. You don't, I very strongly align and agree with like the DAC model, where like you want defensive accelerationism, where you want to accelerate progress and push forward, but you don't want to do it in such a way that like you blow up like the entire species, right? And so you want to be careful about what kind of resources you give to AI agents. It's kind of funny, but like, or darkly funny, a lot of us talked about this happening and predicted this exact moment where we are in 2010, 2012, 2013 as Bitcoin was emerging. And so it's been cool to see like now finally like reality catching up to this. Roughly on time, maybe a little bit sooner than a lot of us expected, but not off by like a factor of 2 or 3. Like I think a lot of us put this kind of moment somewhere between now and 2030, 2032. And so I think we'll start seeing a lot more of these kinds of developments in the next 5-10 years.
Yeah, makes sense. Yeah, I think one of the things, not to wrap up with a bunch of philosophy questions, right? But it gets tricky to define exactly what an agent is. I think one of the things that feels exciting with respect to DAOs, or I think, is this idea of preference solicitation, that if you could, let's say, answer some questions, you would have some AI that was capable of representing your interest in some specific field, right? And then the idea of who's running the DAO, it would be effectively people with some sort of noise or something like that, right? If agents themselves, like this movement toward, like you mentioned truth terminal before, right? Insofar as we think of these things as autonomous, there's something a little unpredictable about it. And so when we think about like a DAC, which is a term I haven't heard before, are we thinking about a DAC as primarily differentiated as like hierarchical, or what's the
original DAC concept was introduced along with DAOs. I think Vitalik introduced both of these in one blog post. There's an old blog post called DACs and DAOs, or DAOs and DACs or something, and it introduces both.
Is the difference just like
And by the way, like a lot of people contributed to that kind of framing around the time. It's just Vitalik was like really good at like describing the whole swath and giving people a really good framework to like run with. And so there's like a lot of really good knowledge embedded in all those old posts.
Totally, yeah, makes sense. But yeah, this question of what these things look like, insofar as they look sort of like our interest represented with some noise, that kind of agentic model, we can understand what it's going to look like. If it isn't, then what can you say about it, right?
I mean, so I think we definitely want to build organizations of AI agents that way to preserve alignment with a bunch of human goals and values and so on. And there you both want to align them to like the parties that are constructing these things and align them to broadly larger groups, because we are talking about extremely powerful capabilities here. We're talking about agents that are able to operate much faster than humans, and you can have whole fleets of thousands to millions of them, right? So imagine being able to recruit 1 million people to do something, like by just running a program. Like that's the world at which we are entering. And the more intelligent this model gets, the smarter the entire fleet will get. And pretty soon, as we have robotics emerging, things like we already have in the world a lot of drones and a lot of other kinds of robots. We now starting to have robotic cars. And pretty soon we'll have robotic humanoids. Like there's now several companies going after that, including Tesla. The moment that I think people greatly underestimate the humanoid thing. I think people don't Is it one of those cases where again the market isn't actually pricing this in? Elon has multiple times talked about how hard it is to build and manufacture these kinds of robotics, and we now have the Tesla gigafactories everywhere, in several continents. And Elon and Tesla are retooling the entire factory to be able to mass produce humanoids. By 2030, we'll probably have thousands to millions of humanoids if we can grab on to a good enough problem that they can solve. This might turn out to be a little bit later, but it's not 15, 20 years out. This is 5 to 10 years out. And so I think people are greatly underestimate the shift in the world that's going to cause. And so when we come back to agents, we're now talking about fleets of AI models that can do a bunch of things online, and soon we'll have real world capabilities. And so that totally changes the landscape for humanity. And so we have to do a lot of philosophy and ethics and policy work really fast to figure out how this landscape is going to evolve to make sure that it's oriented well with humanity and our future. And I do think that like the best path in that direction, if you're technical, and sorry, here technical, I don't mean technical, non-technical. I mean like if you want to build technology, no matter what walk of life you come from, the best path on this is probably neurotechnology, is like the way that humanity has like a very good outcome. But that's a whole other plug for a totally different set of things.
Great. Well, I think we're at time. Appreciate your time, Juan. Thanks, everybody.
Thanks.
Appreciate it.